as Paul for cryogenic tanking, Atlas's propulsion.
Ready.
Hydraulics.
Ready.
Pneumatics.
Ready.
LO2.
Ready.
Water.
Ready.
Centaur systems propulsion. Ready.
Exploring
Pneumatics.
Mars is
Ready.
hard.
LO2.
Everything about
Ready.
it.
LH2.
To send
Ready.
rovers there and other
Basket.
spacecraft,
Ready.
rocket scientists and engineers have to overcome
Ready.
some serious
Ground.
challenges.
Ready.
Facility.
But the rewards are tremendous.
RFFTS.
There may have been life on
Flight
Mars.
control.
There may
Ready.
still be life on
GCQ.
Mars.
Ready.
It is the
Optical
only
support.
planet nearby
Ready.
that we may one day live
Ready.
and have a permanent
Ability.
human presence.
Ready.
UCS.
We have to learn
Ready.
everything we
Ready.
possibly can
Ready.
about the red planet
Quality.
before we
Ready.
send humans there.
Op safety manager.
We don't want
Ready.
any surprises for our
Ready.
astronauts.
Ready.
Help is a long,
Ready.
long way
Rain
away.
and weather. Ready.
It is time to send a new robotic explorer, more capable than any that have gone before. It's time to launch Mars 2020.
Proceeding with the count. ALC, verify count to start at 0920 Zulu.
Verified.
Mars still has many secrets we have yet to uncover. And every 2 years, we get an excellent opportunity to send a spacecraft there. That's when Mars is closest to Earth, only 35 million miles. That may sound like a lot, but it's better than 250 million miles when Mars is on the other side of the Sun. 2 years have come and gone since the InSight lander launched from Earth to Mars. Now, the planets have realigned. A new Mars rover is ready for its mission, and the Atlas V is starting to begin launch preparations here at Cape Canaveral Space Force Station's Space Launch Complex 41. Right now, cryogenic liquid oxygen is being pumped into the massive Atlas V booster stage and Centaur second stage. In 3 hours, the launch window will open, and if all systems are ready and the range is clear, this 1.17 million pound machine will blast off into space, sending the Perseverance Rover on its way to Mars. We have all heard rocket science is hard. Well, it is. These NASA and ULA engineers and scientists are so good at what they do, they make it look easy. But it is not. There is a tremendous amount of planning and engineering that goes into planetary exploration. We want to take you on a behind-the-scenes, all-access tour into what it takes to get a Mars mission like this off the ground and onto the surface of Mars. So buckle up and let's get going. We have sent more spacecraft to Mars than any other planet in our solar system. Over 56 robotic missions have been sent to the Red Planet from countries all over the world in the last 60 years, and only 26 of them have survived. Most of them don't make it through the atmosphere of Mars. Some of them never made it at all. There is a lot that can go wrong during Mars missions. NASA is on a winning streak, having been successful the last 8 attempts. They have even set up a telecommunications network between Mars and Earth for current and future missions. We know more about Mars than any other body in the solar system. But it seems every time we get answers, we get more questions. NASA has found water flowed in the past, but was it once warm enough to support life? Could there be some form of life today? These are some of the questions Mars 2020 will try to answer by visiting an ancient lake and delta known as Jezero Crater. Meet the Mars Perseverance Rover, an engineering marvel, a nuclear-powered geologist complete with a mobile science lab and even a helicopter on board that will attempt to fly in the thin Martian atmosphere. A first for NASA, and if it works, we may see more powerful Mars helicopters in the future. Even though we have sent all these robotic explorers to Mars, it doesn't get any easier. More advanced landing systems need to be engineered, and more advanced systems usually means more weight. For rocket scientists, more weight means more thrust. To get to Mars, you need a powerful rocket to get all that hardware off the ground and travel millions of miles through deep space. And timing is everything. Earth and Mars have to be in the right alignment for launch, and there's a relatively short launch window. That means there are only a few weeks when everything has to be ready to go. The rover and all of its scientific payloads, the cruise stage and re-entry systems, the rocket and all of its components, the ground stations, everything has to be perfect and ready to launch. That's a lot of pieces and parts and people to coordinate all over the Earth. If we miss the window, we'll have to wait another 2 years. For the Mars 2020 mission, NASA chose an Atlas V with a 5-meter diameter fairing and 4 solid rocket boosters for extra thrust at liftoff. Whichever Atlas V the mission requires, there is basically the same procedures to get ready for a mission. The rocket components arrive at Cape Canaveral by sea and are transferred to the Vertical Integration Facility at Space Launch Complex 41, where they are assembled. The spacecraft gets prepared for launch in a specialized cleanroom facility nearby. Once it's all ready to go, the ULA team encapsulates the spacecraft with a payload fairing to protect it on its high-speed journey through the atmosphere. The massive 5-meter fairing is made entirely of carbon fiber. This design is incredibly strong, but also lightweight. Once the spacecraft is ready to leave the cleanroom, ULA uses a special multi-wheel transport system to get it from the processing high bay to Space Launch Complex 41. The K-MAG puts the payload precisely under the VIF's crane, and the ULA pad crew carefully hoists it on top of the Atlas V. This final, very delicate lifting operation is the last piece of integration that needs to happen. Now, the rocket and spacecraft assembly is complete and ready for integrated testing before launch. When everything has been checked and rechecked and all systems are ready, the massive stack of the Atlas V, its mobile launch platform, and its Mars-bound payload is rolled to the launch pad.
Yeah, Step 300 Atlas mechanical MLP roll preps are complete.
Roger. Its engineer, proceed with MLP transport to pad. Roger.
The ground crews and mission controllers roll the MLP with the Atlas V stack on railroad tracks the quarter-mile distance from the VIF to the pad, a procedure that takes about an hour. The spacecraft is monitored by a special fiber optic cable during the transit and is provided air conditioning and power along the way. The engineers make sure everything is perfect. There are no repair crews on Mars. Once the spacecraft leaves Earth, that's it. It's on its own. Only software fixes and guidance corrections can be done remotely. When the launch window approaches, the Atlas V will be fueled up and ready to launch. NASA and JPL started work on this project 10 years ago, and it's finally ready for launch. All the hard work of planning, designing, engineering, and assembly is poised on the launch pad. Next stop, Jezero Crater on Mars. It's a beautiful morning. All systems are go, and the range is green. The Atlas V and Centaur are fully loaded and ready to launch. The mission controllers are ready to restart the count to target liftoff at the opening of the launch window. Before terminal count is started, the ULA launch conductor will poll the team to make sure everyone is ready for flight.
Status check to proceed with terminal count. Atlas systems, propulsion. Go. Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion. Go. Pneumatics. Go.
This is it. The final go, no-go poll. The entire launch team is asked if they're ready for launch. They reply go or no-go. How is the rocket?
Go.
How about the weather? Is the range clear? Is the spacecraft ready? Once the engines are lit, that's it. Mars 2020, you are on your own. Let's listen in.
Vehicle system engineer. Go. Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch Director.
LD is go, and you have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1150 Zulu.
Verified. Spacecraft on internal power and timer set for T0 of 1150 Zulu.
All steps are complete prior to terminal count. LC switch is ready.
That's it. Everything is go. Terminal count has started. The clock is ticking.
Rock, report range status.
Range green.
ECS reduced for launch.
Roger.
25 seconds.
Status check.
Go, Atlas.
Go, Centaur.
Go Mars 2020.
Eight, 7, 6, 5, 4. Engine ignition. 2, 1, 0. And liftoff. As the countdown to Mars continues, the Perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas V is now supersonic.
The Atlas V RD-180 engine is now burning around 2,600 pounds of RP1 in liquid oxygen per second, generating 860,000 pounds of thrust.
And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. The RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly.
Once the solid rocket boosters have used all their fuel, they are jettisoned. No need to carry any extra weight to orbit.
And we have good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison. And we have good indication of Atlas Centaur separation.
Now the Centaur fires its liquid oxygen and liquid hydrogen RL-10 engine, generating nearly 23,000 pounds of thrust.
And we have MES-1. RL-10 operating parameters look good.
After the Atlas booster stage is jettisoned, the Centaur's second stage and spacecraft weigh just over 5% of what it did at liftoff.
Be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
Centaur has 2 engine burns planned. The first is an orbital insertion burn. 30 minutes later, when the spacecraft is aligned with Mars, the RL-10 fires again for an Earth escape trajectory toward its target. Since Earth and Mars are both moving, the actual distance the spacecraft has to travel between the planets is 354 million miles. Once the desired cruise speed is reached, the spacecraft separates from Centaur and is on its way to Mars.
And we have successful separation of Mars 2020 with the Perseverance Rover.
The Perseverance Rover will arrive on Thursday, February 18th, 2021, after 7 long months traveling between Earth and Mars. The cruise stage will make a few planned course corrections along the way before hitting the Martian atmosphere at 12,000 miles per hour. On Earth, it's impossible to test the whole entry, descent, and landing systems. Only the individual components can be tested one at a time to simulate the intense temperatures and speeds they'll encounter when entering an alien world. NASA tested the parachute in a massive wind tunnel to see if it would deploy correctly and withstand the forces of deceleration. Sky crane and other components were tested in laboratories at JPL. But the only way to know if it's all going to work is to actually do it. It took many months to put it all together, but when it hits the atmosphere of Mars, it will only take 7 minutes to come apart. Let's listen in to JPL Mission Control in California as we approach the historic landing of the Perseverance Rover on the surface of Mars.
We're continuing to receive tones from Perseverance, standing by for cruise stage separation. We have indication that cruise stage separation has been confirmed by the spacecraft. We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration.
Indicate chute deployed.
The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds and the heat shield has been separated.
Back shell set.
We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second. We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity. Skycam maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
Looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the first image.
We are just beginning to see a few images coming back now, with many more to come. Perseverance is safe on Mars. Stay tuned to what Perseverance discovers. Be sure to watch the historic flight of Ingenuity, the first helicopter flight on another world. Go Perseverance. Go Ingenuity. Go Mars 2020.